Let's get started. What we're going to be doing now is, instead of expanding, we're going to be contracting. In other words, move this back to a single logarithm. Okay. Now, if you've got powers, that's the first thing you've got to undo. And I have a power here, here, and here. So I've got to move them here, here, and there. So that'll be the first step that I'll do. Now, from this point forward, they're not going to really do it the way I want you to do it. Okay. The way I would have you do this, they distribute them and make it more complicated than it needs to be. Basically, this is a plus, it's going to be in the numerator. This is a minus, it's going to be in the denominator. This is a plus, it's going to be in the numerator. Okay. So I would have you just simply put log x squared z cubed over to the 1/2. Is there any reason not to go straight to that? If it's a minus, it's got to be in the denominator. If it's a plus, it's got to be in the numerator. Now, there is one other step you could do on this. You could write this log of x squared z cubed square root of y. Now, I know I told you thou shalt not put a radical in the denominator. Okay. With a log, you can. Okay. Either one of those two answers would be 4-point answers. Any questions about doing this problem? I'll go ahead and run through the steps that you'll see that they ultimately get the same answer that I get. See what I mean about they're doing the grouping thing and separating out the pluses and minuses that way? I really don't see any point whatsoever in doing those steps right there. Okay. Because here, I mean, you've got a positive. I didn't even reorder them, which they did. If they're positives, they go on top. If they're negatives, they go on bottom. Simple. And keep it simple. Okay, this is page 19, I believe, in your packet. If you get it out, please. By the way, did everyone see this, at least the second email that I sent you today through Blackboard? The first one I had to edit and add a couple of sentences to, but it has the video for the topic that we don't cover in this test, but they'll be on Alex. And so anyway, on this page, this is just a comparison sheet for natural logs, standard logs, and exponents. Okay, that's all this is. Here we have natural log of 1. Well, and here are these others. That and this is the same, except this is the log base e of 1. Now, the important thing on this one is that, remember, this is always the power. This is always the power. So anything to the 0 power is going to be 1. So that's the way you need to think of this one. So if you have a 1 here, it's 0 power. This one, on the other hand, says you have a first power. Well, that means it's itself. In reality, this means log base e of e. Anything of itself is 1. 1 to any power is itself. Okay. Here, the power rule. I've been telling you have to move that out front. Well, based on this business, this part right there is equal to 1. So we have P times 1 is P. So do you need to show all of this stuff? Well, if you've got an E of E, which is what this is, then your answer is going to be P. Or whatever number is out there. This one likewise means the same thing. This right here means base E of X. So we've got an E of E once again. So the answer then is X. So that's the way these things work. Okay, the standard and exponential. Anything to the 0 power is 1. Okay. Anything to the first power is itself. In this case, whoops, wrong button. Okay. Basically, what we're doing is we're bringing the P out front. Those are 1, so the answer is P. Remember back here, when we had something like that, I said you could pull the base and just use those. Well, that gives you a truth. P equals P. Here again, we've got a B of B situation. And there may be a problem in a few minutes if you question something about this or this. We'll be looking to see if anyone thinks of that when we get there. All right, now, these are just more of the problems, okay? This is the multiplication property or product property, where if you have the same base and 2 exponents multiplied, you their exponents. Okay. Here is the division one. If you divide, you subtract the exponents. Okay, and then the power, or they just call it the power property. I call it power, where you move that out front once again. So simplify this. Answer is 1. Okay. Simplify that. Well, the answer in this case is 0, because natural log E of anything where you've got the argument 1, you're going to have 0 power, because anything to the 0 power is 1. Okay, in this case, we have an E of E here. It's just going to be X plus 1. Why even go through the work of the power property? Just write down X plus 1. Here is 1. Okay, now we're going to contract these again. Okay. I've got a plus, a and a minus. That means I'm going to have two denominator terms in the denominator and 1 in the numerator. Okay. First thing we got to do is unpower. Now, once again, they're going to do it with a bunch of extra steps. And from this line right here, all you need to do is ln the x and over y to the 1/3 z. Since both of these are in the denominator, I mean, minus, they will both be in the denominator. Okay? So you can go straight to that. Now, there's one more step you can do on this one, but don't necessarily have to. Now, see, they're going through that business again. And they're going straight to here, is what I would have. Now, the only other remaining step is if you want to change this to the cube root of y. Now, let's start working on equations. Some of this stuff in just a moment you may want to write down. Now, you've seen this before where we pull the b's and just have the x equal y. That's the equivalence property. Sometimes removing the base from both sides is your way to go about solving an equation. Okay? Sometimes removing a log from both sides. Sometimes adding a log to both sides. When I say log, that could be natural log just as well. Now, let's look at these. These are steps you might want to write down. Either that or take a picture of. Isolate the logarithms on one side of the equation. Write a sum or difference. In other words, contract. I would put the word contract in parentheses behind this. From a spread out thing, simplify to a single rhythm if you can. Okay? Then take that logarithm and convert it to exponential. Okay? Base stays the same, power comes over, and then the argument. Solve the exponential equation. And then they say to check it to make sure that you don't have any unsupportable answers. Okay? Sure. Okay, tell me when you're ready. Anyone not ready? Say again. Okay. Okay, here's a different set of rules for a different type of problem. Now we're solving exponential equations. Okay, usually this is saying we usually can't get one of them to be a power of the other, like we had done before. So this is telling us how to deal with it if you've got a base and an argument that aren't powers of each other. You isolate the exponential, you take a log on both sides, then you use the power property to get the answer. And we'll look at some of those in a moment. Now, what about this one? Here's an exponential. This is an example of those last three rules. 2 and 50 don't share a power. Okay? So, in this case, we take log of this side, log of that side. Goes back to the old rule, as long as you do the same thing to both sides, it's okay. Now, Using the power rule, I bring this x out front. And it equals that. So now I divide both sides by log of 2. And I get this. Okay. Now, this is not the same thing as that. This, where we got a single log, we could divide that out and get 25. But this we can't. We got a couple of ways of solving this from here. We can look up the log of 50, look up the log of 2, and do a long division nasty problem. Okay. We could, and there's just those. Okay. Now, they didn't tell you how they went from this to this. How you go from this to that. Whoops, wrong button. Let's try this button. Okay, so what do I want to do? I want to put in fraction log of 50 divided by, go down, whoops, I didn't close my parentheses, divided by log of 2 equals. Okay. There is one other way you can do this one. You still need a calculator to do it. Remember the change of base formula? Anyone remember that? See, if you had log of base 2 of 50 equal to log of 50 over log of 2. Anyone remember that change of base formula? No? Yeah, a couple of heads nodding. You could use that and use that special on your Casio to figure this out. Okay. This becomes that using the change of base formula backwards. Okay. Well, let's prove it. I got to put the 2 in there. Go up or over. Put the 50 in. Equals. Okay. So that's just an alternative way that once you got to this, you could find that number. And remember, this being a rounded off value, you've got to use the approximately symbol. Okay. Questions on this one before I go on? Yes.
Would you prefer rounded off values in the test?
Typically four digits. Typically.
Are you going to specify on the test?
Assume. Okay. Now, most semesters on the final, you don't even need a calculator on the final. You can do the logarithm by just some of the tricks we've talked about. Okay. But it comes in handy. On change of base, you darn sure better write down those steps over there. Okay, because that's what you're being graded on, not a number. And I lost my eraser. There it is. Okay, here is another one. This time we're using E. This is an exponential. So we add a natural log on both sides, giving us a natural log E, which is 1, right? Natural log E is equal to 1 because it's log base E. Okay, so I get this equals that stuff over there. I basically brought this out front. That's equal to 1, leaving this. Well, I want to find W by itself. So I divide both sides by negative 0.25 right here. Then this is what I put into my calculator. Fraction key, LN12, go down, negative 0.25 equals, and it'll give you that answer. In this case, they just rounded it off to 2 digits. If I don't specify, assume 4. Any questions on this one? Yes.
What happened to the LN, on the left side?
Right here?
Yeah, what happened to LN?
Okay.
Yeah.
Now, here's some more strategies. The kind of stuff you might want to write down or copy. And this is going to take a couple of pages. I'm going to fill the page up with this. Here we go. Okay, now, equations having variables in a logarithm, okay, or a logarithmic equations. Here's another example of one. To solve them, first, you contract this, so you got to take a logarithm. Okay. Then you convert it to exponential. Then you use exponential things we just did. Okay, so let's go on. Here's an example of one. Okay, we're going to convert this to an exponential form. The force, the base remains the same. Here's your power. Remember, that's always the power equals Zx. This chance converts to this, and ultimately 1/64. Now, they just did a check over here to see if it's true. And it did work out because 4 to the third is 64. So 4 to the negative third is 1/64. Okay, here's one where we're going to have to do a little bit of a complicated contraction. We've got 2 terms here. We're going to treat this as if it were a single term. Like in this case, I just wrote an M. So that's nothing more than M. This is nothing more than N. Well, if I did that, I would have log of M because they're both plus. So instead of Mn, I have x plus 1, x minus 1. That means I'm going to get 2 solutions in this thing. Now, I'm going to convert this thing into exponential. And I'm going to treat that whole parentheses as if it were one single term. Okay? The base would remain the same. Here's the power, and here's the long-winded argument. That becomes 8. Move the 1 over, it becomes 9. And you get plus or minus 3. Now, you also could have moved the 8 this way, and you would have gotten x squared minus 9 equals 0, which was factor. The x minus 3, x plus 3 equals 0, which would give you x equal plus or minus 3 that way also. Okay. If that's a plus, you darn sure can't do that though. All right. Because it'll give you an imaginary answer. Now, we do need to check this thing. We've got these two answers. We've got positive 3 and we've got negative 3. So we substitute the positive 3 in. Now, they went on down and they saw that it does give you a truth. But simply look at this. 3 plus 4, 3 minus 1 is 2. Both of these have positive numbers in them. If either one of these would end up with a negative, then that would have been an automatic kick. Okay. Negative 3. Put the negative 3 in here, the negative 2. Put the negative 3 in here, we get a negative 4. Neither one of these can exist because you can't have a negative argument. Okay. Most of the time, just checking like this is going to be good enough, and you don't have to bring it down all the way down. Okay. Okay, here we got an exponential. What do? Put a log on both sides. Either a log or a natural log, it doesn't. Okay. Now, if we do that, then we're going to take this, bring it out front using the power rule. Now then, I've got.
I have a question.
Sure.
Why didn't you pick natural log instead of regular log?
Wouldn't matter on this problem. Now, if you had an E in there, it would matter. But when it doesn't, it really, either one will work. Okay. Now, I want to isolate that X. So that means I've got this and that I need to get out of this side. So I'm going to divide by negative 0.02 natural log 3. And over here, I'm going to divide by negative 0.02 natural log 3. Okay. And I've probably done that big enough that I may have to erase it. Well, not quite. So when I do that, well, I actually showed it here, didn't I? When I do that, this and that will cancel with that, leaving this business over here equals X. Then it's a matter of putting this into your calculator. Does anyone want to see me put that one in the calculator? Okay, fraction key, natural log 0.07, close it up, go down 0.02 natural log 3. In my other class, I accidentally hit the log key instead of the natural key there, and that caused me to have a bad answer. So just be cautious. Equals Okay,
Is that one?
what?
Where's the one? Back there. Yeah, that.
Oh, the key right here.
Oh.
Right next to the log key. Okay, so. What about this one? We got logs everywhere in this one. Okay. Now, when you've got logs on both sides of the equal sign, there's kind of a nice little trick you can do. Remember before when we removed the base on both sides? The trick is we're going to remove log on both sides. But before we can do that, we have to get it down to a single log on each side. You can't have multiple logs on one or the other sides. We've got to contract this. That's a minus. That means this x minus 4 is going to be in the denominator. So here's the x in the numerator, the x minus 4 in the denominator. So we contracted this. Now we're going to remove both of these natural logs, which just gives me this equation. Well, that's an equation we've solved before. How do you do it? Common denominator is x minus 4. So we multiply x minus 4 on both sides. These two cancel. X. And over here you distribute that, getting 3x minus 12. Well, you simplify that equation and you get x equals 6. And it will check. If you put a 6 there, you're okay. If you put a 6 there, you're okay. And you can't put a 6 there. So that's kind of your check. Any questions on this one before I go on? Sure. Let me know. This problem, if those had all three been log, the problem would have been exactly the same. Okay, now take it on the other side. Now we have almost an exponential, except we got 3 in front. So we got to divide both sides by 3, and we end up with that. So we have that e isolated. Now this is an exponential value. So we're going to take natural log on both sides because it's an e. We could either take natural log, or we could take log base e on both sides. We could do either one, okay? And anyway, whether it's in this form or whether it's in that form, this part right here is going to be equal to 1. So you got the 2x equals that. Now, at this point, you got to divide both sides by 2, or multiply both sides by the reciprocal, which would be the better in this case, because you don't want to make that a compound fraction, because it would be like that, not just up here. Okay, so anyway, you got this, and other than putting it into the calculator, that's about all you can do on this one. And they did go ahead and do it. Anyone need to see this one put in the calculator, the sequence? Yes? Okay, what did I do? I switched problems. So I've got 1/2 natural log 7/3. Okay. Fraction 1/2. Get out of it. Now put natural log fraction 7. Got to go back there and close that parentheses. Over 3. And wait a minute, I goofed. I didn't close the parentheses correctly. Okay, I put in the 3, then I get out of that whole fraction, and then I put the parentheses. Okay, and then the equal key. That one's a little complicated because you've got the two fractions. Okay. Any questions on this one before we go on? All right. And here's the next one. These don't have the same base, so we can't just take the 2 powers. Okay. But we can put this log on them like that. Now we can use the power rule here and there. We take those powers up front. And what that's done for us is it's gotten these 2x out of the power level into the ground floor level. Okay. And I've got x's here and I've got x's here. Well, let's factor them out and get all of the f on the same side. Well, first of all, I distribute this and I distribute that. 3x log 2 minus 2 log 2, 2x log 3, and log 3. Now at that point, I can move this 2x log 3 over to this side, move that over to the other side. Okay? By adding their opposites. Now then, I've got a 3x here and a 2x there. I can factor an x out of both of those. So I can factor the x out of this, leaving me that. And over here, I don't need to. So I want to get x by itself, so I divide both sides by this stuff, by all of that. Okay. And at this point, you put it in the calculator, and that's what you get. Now, does anyone need to see that? No? Okay. Okay, you ready? Okay, now notice the difference in these two. What commonalities and differences do they have? Well, they both got two logarithms on the left side. But here, you got a logarithm on the right, here you got a number on the right. It makes a difference how you solve these. Where you got this number on the right, your strategy is going to be contract to a single logarithm, convert to exponential, and solve the exponential. This one, you're going to contract again, so you got a single log on both sides, and then you're going to remove that log on both sides. So that's your two different strategies on these two different style problems. Okay. Well, here it's going to tell you a little bit about that. For solving the first type, we'll use the equivalence property of that business. So here, they started with a second one. We don't have to contract on this one. Okay. We'll get a contraction one in a minute. But we're starting with a more simple one. We've just got a log on both sides. So what are we going to do? We're going to remove the log on both sides. Being a simple algebraic equation to solve. We get the answer. We put a 6 where both of these x's are and see if that causes us to have a negative value, a negative argument. And it doesn't. So these answers are good, yes.
So the only reason that you're able to get it down to that equation is because both of those are log 2, they just cancel each other.
Yeah, as long as these are both the same log base, you can remove them.
All right.
Now, if that was a log 2, it's a log 3, then you can't do that.
That's where you move them.
Well, that's a whole different kind of a problem. Okay. Now, anyone not ready to go on this example? Okay, here's a second example of the same type. Log on both sides. X equals 6 again. Well, if we put 6 in here, we get a negative value. That blows us out of the water. That means our answer is no good. That means in this case, it is undefined. Why? Because this 6 put in there gives us a negative argument. Here, if we put the 6 here, we get a negative argument in that one also. But it wouldn't have to be in both. It only have to be in one of them for it to make it undefined. Okay. So no solution on that one. Here's our one we got to do contraction on now. We've got a numerator and we got a denominator in our contraction. Okay. That's going to give us that. Now, I've got a single log on one side, a single log on the other side. So I can remove the two logs. And that leaves me this equation to solve. Well, common denominator of x plus 1. So they didn't show it. But I took x plus 1 here, and I took x plus 1 here. These two canceled. That one gives me that. And then I have this because this is 1. So I continue, and I get x equals 6 again. You're not going to get 6 on everything. It's just worked out that way. But we got to test that 6. 3 times 6 is 18 minus 4 is 14. We're positive 14. We're good. 6 plus 1 is 7. We're good. And that one we can't replace. So this is a solid answer. Any questions on this one? Another contraction, this time using natural logs. Here's my numerator, that's also in the numerator. So I get that equals this business. Now I remove both natural logs. X times x is x squared, x times 3 is 3x. That's 10. We're going to bring the 10 over. And that's something we can either factor or use quadratic formula on. Either factor or use quadratic formula. Make yourself a note at this line about that. Now, this one does factor pretty easily into that. So that means we're going to have two answers. We're going to have an answer of -5 and an answer of +2. So we got to check them both. We put -5 up here, not going to work. I'll get a negative argument. Okay. If I put a -5 right there, I'm going to get a negative argument. So obviously this -5 doesn't. Let's try the 2 before we make the assumption that it works. +3 is 5, 2 there, okay, 2 is good. And I'm implying here that you've got log of a -x as a reason. No. I just did that. Yes.
So if only one of them works, then you just.
Whoa. Louder, please.
So if it only has one solution, we just put that, or did it just completely like throw the whole equation?
No, if that solution works, you got to put it. Did I answer your question?
Yeah.
Okay. Just count, throw it out. Got a little nastier one here. Some repower to do. And then we've got some contraction to do. Here we brought the 2 back up. Okay. And both of these plus, so both of them are in the numerator. I'll have to distribute that maybe in a little bit or maybe not. Okay, so if I take this log base 3 away from both sides, it leaves me with this thing. Now, they did go ahead and distribute that too. Okay. So I get that, get everything on one side, factor it. Factors into this, or you could have used the quadratic, would have been more work. And you get those 2 answers this time. So we got to go up and check them. Okay. If I put a 4 there, I'm okay. If I put a 4 there, I get 12 minus 4 is 8, so I'm okay. If I try the 2 there, I'm okay. And if I try 2 there, I get 6 minus 4. So I'm okay there also. So both of those are solutions to this problem. Questions on this one?
Question.
Sure.
So you know how you have log 2 plus log 3x?
Right where? Right here?
Just the very top.
Uh-huh.
You know how it's 2 plus
Uh-huh.
comes to multiplication of 3x.
Say the last sentence louder.
So you know how it's 2 plus?
This plus that, log 2, log this.
Why did it become 2 multiply x, 3x minus 4?
Okay, what if I had log 3 of y plus log 3 of 3x minus 4? If I had that, since both of these are pluses, That means they both go in the numerator. Okay, so I would have had log 3 of y times 3x minus 4. Only difference is I got a 2 instead of a y. Okay, you
Yeah,
okay?
that makes-
All right, so we'll go on then. Both solutions check. Whoops. Okay, now we're going to work with ones that have a number on one side or somewhere, just a plain number, and then logarithms. Okay, up to this point, we've been dealing with all logarithm terms. Okay. So we're dealing one with that. Well, you got one like this. The only way to deal with it is by changing it to exponential. Power stays the same. Excuse me, base stays the same. Here's the power, and there's the argument. So this becomes that. We're treating this like it's just one term. We're treating that it was just one term. Okay. Now, 5 squared happens to be 25. So we can simplify this, get numbers on one side, variables on the other, divide by 3, and we get 8 for the answer. Well, we better check it. Okay. 3 times 24 plus 25. We're good. Question? Okay, another one, a little more complicated this time. This time we're going to have to do a contraction before we can switch to exponential. But because we got the number over here, our strategy is change to exponential. So we got the same base, so we can put both under log 3. We're going to treat that like one term, that one term. This one's going to be a numerator plus term. That's minus is going to make that a denominator term. So this thing's going to look like that. Okay, does everyone understand how I went from this to there before I go any farther? Because this is the critical step of the whole problem.
How is the log of what's already-
Okay. This is one term. That's one term. This one is a positive, so it's got to go in the numerator. That one is a minus, so it's got to go in the denominator when we contract terms. Did I answer your question?
No,
Okay, try me again then.
the log 3 is on the left, like there's 2 log 3s, there's that one and there's that one.
Yeah,
Why is there just one left and it's on the left side? Like the log 3.
when I contracted this, I contracted it to a single log. It happened to be base 3 both times. Okay,
I got it.
fact is, you can't do this contraction if those bases are different.
Gotcha.
Those bases must be the same. So whatever the pair of them were here will also be this one. Now have I answered your question? Okay. All right, well, here's the next step. Converted this thing exponential. The base 3 remains the same. Here is your power. And here is your argument. I know I usually like to put the exponent on the left, but I mean, that's just me. It's just a habit I have. So how do I finish this out? Well, I multiply both sides by a common denominator, x minus 2. I can cancel these two. And I get that, which simplifies to that, which simplifies to that. Now, what have I got left? Check. So we'll take this 3. 3 plus 6 is 9, that's good. 3 minus 2 is 1, that's good. So that's a good answer. Here's this one looks iffy, but in reality, it's like the last problem. We got this 2 over here, Lone Ranger. So we need to leave it over there, but we need to move this one over here by adding its opposite. So when we do that, we end up with log x plus 15, add its opposite, plus log of x, and then it equals the 2. You know, I suppose you could put plus log x plus log x if you wanted to. Now then, I need to contract these. By the way, speaking of bases, these two are hidden base 10. Numerator here, and I've got another numerator here. So this is going to contract into x times x plus 15. Wouldn't really matter which order you have these two things in. Okay. So now, because we got the number, our strategy is convert to exponential. Base 10. Base 10. So 10 to the second power, okay, equals the argument. Now, anyone not sure before I go any farther? You look skeptical. You look skeptical or?
I was writing down.
Oh, okay.
Is that,
So you're okay now?
so that log just, there's no number there? It's assumed-
Yeah, just log by itself means log base 10. Just like ln means log base e.
Okay.
So we've got this, that's 100. We move that 100 over to the other side, gives us a quadratic that we can either factor or use the quadratic equation on. Okay, so we do that. This thing does factor, by the way. 20 minus 5 is 15. 20 times 5 is 100. Okay, so that gives us two solutions, negative 20 and positive 5. Once we've done that, we need to go back and check. If I put negative 20 right here, it won't work. So I have to throw out the negative 20. Let's try the 5. Well, the 5 works there and the 5 works there. Negative 20 wouldn't work over here either. But it only has to don't work once. That's kind of. Okay, questions on this one?
So the answer on that is 5.
5, yes. That's the sole answer on this one. Okay. Okay, we're gonna have kind of a scary looking one next. And this time, I want you to try it. I want you to try this one. I guarantee you at the end, there's gonna be some factoring to do and canceling to do. But at the beginning, it starts almost like the last one. Okay, that's what your first step ought to look like. If you didn't get that, then we need to be talking about it. And if you did get that, then keep going. Question?
Would the log cancel out and stay on the opposite side of the equal sign?
Where?
Since it's log 4 on the left side, log 4 on the right side of the equal sign, would they not cancel out?
You don't have a log 4 in front of this.
Oh, so the 3 isn't a part of the log 4 then?
No.
That's what it's only.
Yeah.
Oh, okay.
Now, if this parentheses had been out here, yes, we could do that, but it didn't.
On the other side.
Yeah, I added positive 3 to both sides, and I added negative log 4 of x plus 3 to both sides. To get it over. Okay, so at this point, keep going from here. This into one log term. Log 4 of something. In this case, we're gonna have a fraction with both a numerator and a denominator. Yes.
Would you be able to factor the x squared minus sign at the beginning and get rid of the x plus 3?
That would just make it more complicated at the beginning. Yes, you could, but it would not be your advantage. Okay. But eventually, yes, we will have to do that. Okay, here should be your next step. Or your next result. Point, we're ready to convert to exponential. Base is 4, power is 3, and here's the argument. Now you can factor this thing to answer your question. Okay. So your answer then is 67. And we check it. Well, 67 squared is darn sure bigger than -9. And 67 plus 3 is still a positive. So we're good on both tests. Now, what was your confidence level on this problem? I'm asking you.
First part of the 0.
First part of it 0.
I think I get it now. It's just like bringing whatever has to go to each side.
Getting all the logs on one. It's kind of like getting all the X's on one side, all the numbers on the other, kind of a thing. Okay, and other queries about this problem at some point. Yes.
Why was the x plus 3? I thought like maybe we can cancel out the x plus 3 and then just like multiply it with your love.
I'm not sure where you're talking. Are you talking right here?
No, at the bottom, like the third step,
Down here?
more
Here? Here?
right there. Like I thought I would be able to like cancel the denominator with x plus 3.
What would I cancel this x plus 3 with? Here?
If I multiply it.
I don't understand what you're asking. I'm
So are
sorry.
you talking about like multiplying both sides like this?
Yes, that's right.
Well.
Here's what I think you're asking. Maybe I'm wrong. You're saying you got this x squared minus 9 over x plus 3 equals 4 to the third 64. We'll go ahead and do that. I could do this. Okay, those two would cancel. And then I would have x squared minus 9 equals 64x plus whatever 3 times 64 is, 192. I think somebody checked me on that number. Okay, then I would have to combine terms, so I would have x squared minus 64x minus minus 192 minus 9, which is x squared minus 64x minus 201. And then I'd have to factor that thing. Well, guess what? 67 times 3 is 201. Okay. So yeah, you could do it that way, but man, you create a bunch more work for yourself. It's easier to just factor this and then cancel them here. But yes, what you were suggesting can be done. Don't recommend it. All right, any other questions on this? That was a good question. And there might be some problem where that might be the easier way to do it, just not this one. Okay, this page is in your packet. It's either page 20 or 21. One, thank you. Okay, what this is just more examples like we've been going over in class. Now, what I've done in each one of these is I put think in them. This is what you're doing and why you're doing it. Okay, this is just a reference study sheet. Okay, this technically would equal that over that, but if you're using the calculator, you might as well just put log 30, log 15 and get the answer instead of converting the decimals first. Okay, you can see my think steps on all of these. That's just extra information for you guys, okay? For you to review on your own time. We're not going to take class time to do that.